Hi, this is a video for Unit 6, Current and Resistance, and the topics we will talk about in this unit are electric current, current density, resistivity and resistance, electromotive force and Ohm's law, series and parallel resistors, energy and power in electric circuits, and diodes. Okay, our first topic, as I said, is electric current. The definition given by hyperphysics is rate of charge flow past a given point. Now, this means there will be some charge at a given point. Let's call it Q1. And at the same point, let's say some time later, we'll have Q2. And the rate of change between the first time and the second time is called the current. The current is represented with the letter I, and its units are amperes. Now, what ampere means is, well, we know the unit of charge is the coulomb. And since it's the change of charge in time, it's coulomb over second. That is the definition of an ampere. The thing that makes a current move are the electrons, but not exactly, because when an electron moves this way, the current will go the exact opposite way. And this is because of a convention that, well, protons were discovered first, so the protons move the other way than the electrons, and well, it was established that the current would go in the direction of the protons, but in reality what moves are the electrons, since they are lighter than protons and can move easier. Now, just a fact, the charge of an electron is 1.602 times 10 to the minus 19 coulombs. So to get 1 ampere, we need to move, this is negative, sorry, because the charge of an electron is negative. To produce 1 ampere, we need 1.62 times 10 to the 19 electrons to pass at a point in 1 second. That is a very huge number of electrons. Well, it is measured in amperes per square meter. And what this really means is the amount of current in a certain area. We can imply it by the units, amperes per square meter. And well, it is, the area is measured orthogonally or perpendicular to the current. Let's say this is the current, and we have an area like this. My best attempt of a 3D plane. The area is measured like this, and the current is perpendicular when we are measuring current density. Now, our next topic is resistivity and resistance. This may look like the line when you have a device connected to your heart and is measuring your heartbeat, but actually these are resistors. Well, resistance can be explained as the ratio of voltage and current when we are thinking of Ohm's law, that we will explain that later. But when we do not have a resistor connected to a circuit where it has current and voltage, and we need to know the resistance of a resistor alone, what we do is think of its material and know that that material has a constant called resistivity. Resistivity is given by rho, and its units are ohms meter. Ohms meter. And well, the relation between resistivity and resistance is given by the following formula. Resistance equals our resistivity times the length of our wire or whatever we are using as a resistor divided by the area. When this is a wire, it's a cross-sectional area of the wire, but it is applied for any object. And well, what resistors do mainly is to absorb power. We also will talk about power later. To absorb power in a circuit, so it causes a voltage drop. I will explain all of that in a moment. Now I'm going to talk about electromotive force and Ohm's law. Well, electromotive force is the force created by the difference of potential in both sides of a conductor. Let's say here we have a conductor. Here we have, this is positive or more positive than this, and let's call this the negative side. What the electromotive force means is that all the electrons will go in the direction of the positive end of our conductor. So, well, since the electrons move towards the positive end, that means the current will flow towards the negative end. As I explained before, current and electrons go in opposite ways. And now, when we connect a voltage source, let's call it a battery, with some wires like this, and let's put in there some resistors as well. When we connect all of them, imagine like this. This is our wire, and this is our resistor. The wire obviously is a conductor, and well, this means that the electrons will go from the positive end, from the negative end to the positive, so the current will go from the positive to the negative, like this. Well, along this strip, there will be voltage drops. And now I will going to talk about those voltage drops that I talked about before. Well, we start at this point with a certain potential difference, and we need to reach this one. But where is this voltage drop that leads us from this voltage to this negative potential. Well, the potential falls in the resistors. The resistors, what they do is they don't let pass less current. It's exactly the same current, but the difference is that the voltage here will be less. The voltage at this end will be bigger than the voltage at this end. So, well, the resistors are the ones that are in charge of this voltage drop. Actually, the wires also have a voltage drop because there is they have a very small resistivity in them, but it's very small that it's almost negligible. And well, and how can we explain? How can we relate voltage, resistors, current all in one single formula? Well, this is where we have Ohm's law. That is one of the most basic and most elemental and most important rules in electrics. So this is so important that you might need to take a rest, go to vacation, and come back when you're ready. Okay, now that you're ready, I'm going to explain Ohm's law. It's very easy actually. Voltage equals resistance times current. Well, that's all. It is not that difficult. The current that passes through this resistor times the resistor will equals the voltage in the resistor, and the voltage that is in that resistor is the difference between this end and this end. Now we have more light, and that is because there is a current going through my light bulb. And now I will explain resistors in parallel and series. Resistors can be connected in many ways. The two most popular are parallel and series. Parallel means they are connected to the same two nodes or cables. Let's say this is a cable and this is the other one. This is, I'm gonna draw it. And this is a resistor, and this is the other, and this is parallel. And series means they are connected to the same, they only share one cable, but a very important thing here is that there can be another resistor here. This doesn't mean that the three resistors are in series. This is a different configuration that it's not the same. Okay. So, and what does it mean that some resistors are in parallel or in series? Well, when they are in series, the total resistance will be bigger because here we have resistance 1 and here resistance 2. When we connect them in series, our total resistance is R1 plus R2. This is very easy. And when they are in parallel, the total resistance will be smaller because when we put them together, the total resistance is 1 over R1 plus 1 over R2 and 1 over all of these. So it's the inverse of the sum of the inverses. It's not that complicated. not as complicated as it sounds, but well, you just have to get used to doing this kind of calculations. And well, there are many other ways that resistors can be connected, but these are the two most popular. Now, energy and power in electric circuit. Each element in a circuit, call it the voltage source, the resistor, either generates or absorbs power. Well, it's very easy to know which is which. The voltage source will generate, and the resistor will absorb the power. And well, how do we calculate this power that is either generated or absorbed? There is a trick. We know that voltage is Joule over Coulomb, and as we saw at the beginning of the video, the current is Coulomb per second. So if we multiply this, we can get rid of the coulombs and we get Joule over second. Now, Joule over second is the same as watts, and watts is the unit of power. So when we multiply voltage times current, we get our power. So we can get this formula: P equals V times I. And well, it's obvious, at least in direct current, that the voltage will never absorb the power, because it is the one that is creating the electromotive force. And as I explained before, the resistor absorbs, so it let's say lowers the voltage in a circuit. And now to get the energy, well, since watts is joules over second and we need the joules, and we just multiply the power times the time. And well, energy means power is the energy in a period of time. So well, we get that energy equals power times time. Okay, and our last topic are diodes. Diodes first are represented in a circuit like this, like an arrow with this line. Now, diodes are can be conductors or can be resistors. And how does this work? Well, let's say we have a conductor material, that is the green one. And to that we add another element, let's say, another element that will cause it to have less electrons, less valence electrons than it would usually do. And we have another that is just like it, and we add an element that will cause it to have more valence electrons than it would be normal. So this material is one that has four, the green one is one that has 4 valence electrons. Let's say the blue one has 3 and the red one has 5. So when we put it together, they create a diode. Now, the special thing about diodes is that they can or cannot conduct. For example, when we connect it to a source and the positive end uh, matches with the positive side of the diode, the one with less valence electrons, and the negative with the negative, it will work almost as a normal cable. I will explain why almost, but when we have it the other way around, it won't conduct at all. And why does this happen? Because when we have it like this, let's say the electrons won't be able to pass this barrier, this frontier, and they will be stuck like here and here. And once the current tries to pass, it won't be able because the electrons won't move. Now, I said diodes work almost as a cable because it is not how do you say, sufficient that it is connected this way. It needs to break a voltage that is called the breaker's voltage. And for germanium, that is the most common materials for diodes, this voltage equals 0.7 for germanium. Another very common material is silicium, and that is 0.3 volts. Once you have surpassed this voltage, this will work like a cable. Now, diodes are very important in electronics because they have a lot of uses. One of the uses of diodes, one of the most common, is the diode bridge. This looks complex, but it's not that complex. The different thing here is that it has alternate current instead of direct, so that means that the voltage across time will behave like this. Sometimes this end is positive and sometimes it's negative. So, well, let's analyze what this diode bridge does. Well, we have the positive end here, so the diode that will conduct is this one and not this one, because this is positive with positive and positive with negative. This doesn't conduct and this does. So the current goes like this. Now the current can't go through this diode because here we have the negative, so it can only go through this resistor. Then it looks like it can go this way, but remember that the bigger voltage is here. So if there's a bigger voltage here than here, it won't conduct, so it can only go this way, the current. And once it is here, it returns to the source. So it does the whole trip. And the exact opposite happens when let's say this is a negative. I'm sorry, it stopped recording, I don't know why, but well, I was explaining that once the voltage is here, so this is the negative, this is the positive and this is the negative, the current will go like this. It can go this way, so it goes in this way. It can go through this diode, so it crosses the resistor, and then it goes here and it returns to the source. So, well, what this does is, if you can see, both times the current through the resistors goes from right to left, and so even when the voltage is in this way, the voltage in the resistor will be this, but when the voltage in the source is this way, the voltage in the resistor again will be positive. So this is called a wave rectifier, and it is very important in electronics. And well, that's it for video of Unit 6. I hope you liked it and understood it. And I will be making the video of Unit 7.